Assalamualaikum and greeting to all the audience. So as for today, I would like to present our innovation project, which is purposely to facilitate students to understand the concept of wind generation, mainly the renewable energy on general. The project is actually for educational purposes with integration of renewable energy. So, when we discuss on wind energy, our mind normally will associate that the wind turbine is actually like a windmill, a fan type lookalike a wind turbine, which its blade rotates in horizontal positions. That actually quite common when we search on the internet or through the internet. However, in our innovation projects, we focus on quite uncommon, unfamiliar wind turbine, which is vertical axis wind turbine. This kind of wind turbine actually require less spacious and actually in more toward the development. Okay, vertical axis wind turbine. The innovation is exactly like a real vertical axis wind turbine, or in generally VAWT, but in a smaller scale. Okay, in a smaller scale. Okay, the objective of our wind turbine, firstly, to provide a real life wind turbine with actual output. Okay, so as I present earlier, this innovation is for educational purposes to facilitate students for their understanding, to ease their understanding on wind generations. So it actually can be adapted with either indoor or outdoor facilities, purposely in our laboratory or in our institutions. Therefore, we can divide our objective to three major components. The first one is to show and provide students the real form of output, okay, from the wind turbine itself. Normally, a ready-made trainer that come in from the supplier, they have already integrated the wind turbine with the panel, and student just learn it from and measure it basically in DC output. But normally, the actual form of this wind turbine is different, which is in AC. So we make and design this wind turbine, and so it can show the output in signal in AC form, in AC signal. Okay. Then the second one is to show the connections, the connection and the conversions, the usage of the conversion from AC to DC to the students in terms of our energy output with respect to load variations and also the changes of wind speed. Okay, that from our innovations, the wind speed source is from the fan, okay, industrial fan. And lastly, is to reduce the cost of wind turbine. So the panel can be matched up and integrated with other available components and other available equipment within our laboratories, such as measurements meter in AC and DC, resistive load, inductive load, and etc. Thus, it came to this slide to this diagram. If we look at the diagram here, the connection is quite simple. Okay, the connection from the wind turbine itself is quite simple. The VAWT or wind turbine, vertical axis wind turbine is self-made. The stand is self-made, so it can measure and can be portable either outdoor or indoor. So it can be other outdoor or indoor situations, and it connected, okay, to the control panel with AC to DC conversions. So, and from the panel itself, we can show generation both on AC and DC output. Okay, the other available component can be meshed up from the control panel. Then the integration from the panel to the existing equipment. So in this diagram, we can integrate it or mesh with existing component or existing equipment such as oscilloscope for AC signal, and then we can measure it in DC form, okay, DC signal, such as ammeter and voltmeter. And from here, student actually can learn the actual output on AC from the noise, the differences of the frequency that been generated from the wind turbine itself, okay, the phase of AC signal, okay, and from that, the student can learn the purpose of conversions from AC to DC, okay, before integrating it into the grid. So from here, it also facilitates students to know what is exactly the control panel here, okay, and the output, the differences, the variation of current, and of course, voltage, okay, from the variations from AC and DC, the voltage drop, okay, and all of that. As you can see here, after we finish the connections of the wind turbine from the source, wind from the fan, and it rotates the wind turbine, and after that, the wind turbine will generate its electric, and this panel will show the output in AC. We can see it, we can integrate from the panel itself. You can show the output is actually AC, and then this panel also we can we can connect it in ease from point to point, either in AC and DC, and from DC we can vary the load. So we integrate it with the load connection. This example, we use decade resistance to connect to the panel. So this is the output in sinusoidal, and then when we can vary it, we can also show here. You can also show here the output in DC, which is in volt, and also this ammeter. Why we don't do this? We don't build the DC ammeter or DC voltmeter because we already have the panel. So we just integrate. This is what we call easily integrate with what we have available in our lab. So it's easy to students to understand
what is actually the output from the wind turbine, okay, in real life, in real stations, not such in DC, indirect DC, and also why we should convert it. We show them, we teach them why we should convert it into DC first, not just put directly from the output AC. Okay, because of the frequency, we can show the difference of frequency in AC that has been generated from the wind turbine is totally different. It's not synchronized with the grid. So we have to convert it first in DC. This is actually one of the methods before the integration to the grid. Okay, thank you very much.